Welcome back, Honors Geo students. In this section of notes, we're going to be working on Objective 2. I know it says Objective 4 here, but this is Objective 2. And we're going to be talking about percents and ratios, okay? Now, I just want you to understand, this is a fairly hard section because there's a lot of stuff to try to think about. So we're going to try to talk our way through it, make sure that we understand kind of what's taking place, because this is one of the more applicable sections of mathematics that actually applies to your life on a regular basis, okay? So let's get started. Let me go ahead and move myself out of the way here, and we will jump in. All right. So first, let's take a look at the number one level, or at level one questions, and let's look at the first one here. We're talking about that last year at movie night, 350 people attended. This year at movie night, there were 520 people. By what percent did the movie night attendance increase? So this is a classic case where we talk about percentage increase or percentage decrease. And there's a formula we use when we're talking about percentage increase and decrease. It's a real straightforward formula. If we get a positive value, it's increasing, and a negative value means it's decreasing. So what is this formula though? Well, it's whatever the new amount is minus the original amount divided by the original amount. And then we take that and multiply it by 100, that way we get a percent. And so the way to remember is I always just say, no! You know, you have the new minus the O, the original, divided by the original. So no. And again, if we end up with a positive value, this is a percentage increase that took place. And if we have a negative value, this is a percentage decrease that took place. So let's look at this and let's work our way through it, okay? So we have the new minus the original divided by the original minus 100. Let's fill in each one of these values here. What is our new amount in this problem? Well, it said last year at movie night, so last year is before, and then it tells us what the new amount is here, which is 520. So it's 520 is our new amount. Okay, so let's fill in that 520 right there. The original amount, when we look at it, is what we had a long time ago before. Well, we had before 350, and that's going to be the same for the original amount here. So let's go ahead and fill in the 350 for this and the 350 for this. And what we end up with is 520 minus 350 divided by 350. Take that and multiply it by 100, and we get 48.57%. Now it says round to the nearest hundredth. This is going to be important that you pay attention to this. The rounding stuff is very, very important throughout mathematics, especially when we get to higher level math. You have to pay attention, otherwise you're going to lose a ton of points. This says the hundredth. When it says to the nearest hundredth, an easy way to remember how many decimals it is if we say the hundredth, think about the number 100. 100 has two decimal places, or 2 zeros, so that means we go to two decimal places. If we say round to the nearest tenth, we look at tenth, there's only 1 0 there, so that means we go to one decimal place. If we said round to the nearest thousandth, thousandth has 3 zeros, that means we would go to 3 decimal places, okay? Keep track of that as we're working through problems. All right, number 2, about 70% of the people attending the homecoming dance, they attend the dance without a date. So this means if 900 people were to go solo, that means 900 people don't have a date. How many people do attend the dance? Well, if we think about the part out of the total equals the percent out of 100, this is a standard formula that we use when we're doing percentage stuff, is we say part out of total equals percent out of 100. Because when we're looking at the percentage, this 70% that's right here is the portion out of 100. So it's the part out of the total. And so when we set up this problem here, let's take the part and the total and compare it to the percent out of 100, okay? What we're saying here is that 70%, so that's going to be our percentage that's right here. So let's throw a 70 on there, okay? Attending a homecoming dance without a date. 900 people go solo. So this is part of all of the people that went. We had 900 people that went solo and 900 people that went with a date. So what's the total? We don't know what the total is here, okay? So when we say 900 people go solo, this is the part that's taking place right here. It's going to be 900. And the total is what we don't know in this problem, and that's what they're asking us for, is they're saying how many people went to the dance. And so that is our total here, which in math, when we don't know, we call it X. So if we set this up and look at it, we have 900 over x is equal to 70 over 100. Now to solve these problems, remember what you're going to do. You always just cross multiply. This goes back to algebra 1 right here. Cross multiply, we get 90,000 is equal to 70x. Divide both sides by 70, and we end up with approximately, we get a decimal, it's like 1,285 point something. We don't really have portions of people, so we go ahead and round it up to the nearest whole person, which means it's about 1286 people. These double squigglies right here, that's the symbol that we use when we're saying approximately equal to. Okay? For number 3, the Crayola Crayon Company can make 2,400 crayons in 4 minutes. How many crayons can they make in 15 minutes? So this is a classic problem where we talk about ratios and proportions. When we'd say, let's compare one to another. Hang on. Sorry, I thought I sneezed there. We're going to compare one to another. Like in the one above where we say the part is to total equals percent of 100, really that's saying part to total equals part to total. So when we look at this, we're saying the part to total equals part to total. Or in this case, we're going to take this proportion and we're going to go ahead and say part to total equals part to total, or crayons to minutes equals crayons to minutes. Okay, hopefully that makes sense. Comparing apples to oranges, if you will, right? Well, so let's look at each one of our parts. First, they can make 2,400 crayons in 4 minutes. So they can make 2,400 crayons in, when we look at this, we're going to say 4 minutes. Okay, and then we say, well, how many crayons can they make in 15 minutes? So then we say, all right, well, let's go to match up things. We got 15, wrong color. We have 15 minutes here is what they're giving us. So it's 15 minutes. And what we don't know is how many crayons. So we've got a classic problem where we just got a proportion that we set up. 2,400 over 4 is equal to x over 15. Let's cross multiply and solve like we did in the last one. Cross multiply, we get 2,400 times 15 gives us that 36,000 I mean. 4 times x is 4x. Divide by 4, and they can make 9,000 crayons in 15 minutes. Okay? Level 2. Now let's start talking about where there's multiple steps in these problems here, okay? Avery decided she wanted to get a manicure before homecoming. Okay, that's a useful statement. It just tells us kind of what's happening though. The original price at the salon was $45, but she has a coupon for 10% off. If she had to pay 8.75% tax, what is the final price of her manicure? So let's take a look at a receipt. This is not one that relates to the problem. This is just a receipt that I pulled up off the internet, okay? When you look at the pricing of things, what we do is we can see that there's a price right here that was $19.95, and they took 50% off. You don't usually pay tax on discounts. Usually what you do is you take the discount off first, and then you do, later on, you can see, you figure out what the total is with the coupons applied, and then after that, you go ahead and figure out what's the tax that's going to take place, and then we take all of those numbers and put those together to give us our total that's going to take place. So that's the process whenever you're using a coupon and whenever there's discounts and taxes being applied, okay? So let's think about this scenario. It's a $45 manicure, but she has a coupon, which means she gets to take off 10% of this. Well, let's figure out what that 10% is, okay? If she has a coupon, we can say that she has part out of total equals 10% out of 100. It's because we're asking how much of $450 or $45 are we getting off, right? What is 10% of 45? So the part here is unknown. 45 is the total amount. We're going to take 10% of that, and we're going to cross multiply. If we cross multiply and solve, we get that x is equal to $4.50. So her coupon is saving 10% of 45, so her coupon is saving $4.50. So we're going to go ahead and take off, it's going to take off $4.50. So now how much is remaining? Well, if the coupon says $4.50, we're going to take 45 and we're going to subtract $4.50. And whatever this total is, we're still going to owe tax on this. So what's the tax? Well, the tax is $8 or 8.75%. So when we set this up and look at it, it's the same problem we just did. Okay, we have the part is how much is going to be taken off, right? And then this is how much she's going to actually owe from when we took the coupon off. And so when we look at this, it's $40.50 is how much she was going to pay, right? That's how much this is. And we need to know, all right, well, what's 8.75% of this? And if we work through and cross multiply and solve, we get that the tax on this is $3.54, approximately, a little bit more actually, okay? But what they do is they go ahead and round it. They said that this is just going to be $3.54. So now what we do is we're going to say, well, the tax that's going to be added is $3.54. Okay, so at this point, here's what we got. We have $45. We're going to take off the coupon, and then we're going to add the tax, same as what was happening in that other receipt there. So with our $45, we're going to take off $40.50. I'm sorry, $4.50. And then we're going to add $3.54. And we end up with a total of 40 minus 4.5 plus 3.54. She is going to pay $44.04 when all is said and done. Okay. Good stuff. That's an important one to know, you guys, for your future. You're going to need percentage because of taxes and when you go to purchase stuff, and it's a real big deal. All right. All right, next one. Brianna makes $200 a month at her job as a lifeguard. Her mom says she wants to take 20% and save it. She's going to donate 5% to charity. She's going to contribute 30% to car insurance, and then she gets to keep the rest. Okay? So there's a difference between saving and keeping. Saving means you're going to put it into account, and it's just going to sit there, and it's going to earn money in the bank. Keeping means this money that's in my pocket that I get to do whatever I want with it. I can go get myself all glazed up, looking, all fresh with some new shirts and new pants and new shoes. Okay? So I'm going to show you a really easy way to do this. Instead of sitting here calculating how much is going to be saved and how much is going to be donated and how much is going to be put into car stuff, here's what we know. If I take all of these and put these together, she is going to be taking and putting in 25 and 30. So she's going to have 55% of her money is going to be tied up in something. Okay? 55% is going to be tied up in savings, donations, and car stuff, right? So how much does she get to keep? Well, if she didn't put in any of this, she'd get 100%. But because she's putting in 55%, she gets to take 100 minus that 55, 100% minus that 55%, and she gets to keep for herself 45% of the money. Okay? So all we have to really figure out is what's 45% of 200? Well, 45% of 200 is equal to 0.45 times 200. So if we just multiply this, 0.45 times 200, we get $90. Okay? For the next part, it says, all right, well, if she decides to go ahead and increase her charity giving to 10%, now how much less is she going to get to keep for herself? Well, she didn't change how much she's saving, and she didn't change the car stuff. She's just changing the donation amount. And so what ends up happening is this total amount right here is now going to become 60%. So 60% of her money is now going into something, right? She gets to keep the rest. So if we do 100 minus 60, she gets to keep 40%. So now we have to figure out, well, what's 40% of 200? And so she's going to keep 4.40 times 200. So she gets to keep $80. And so how much has changed? How much less does she get? Well, she was getting $90 to keep. Now she only gets to keep $80. She is getting to keeps $10 less. There you go. All right, that's the easy way of doing it. Number 6, at Elk Grove High School, students vote for a live band or a DJ to play music at the school dance. Ratio. Okay, so pay attention to what we said here. We're talking about a ratio here. of live band to DJ is 5 to 20. So what that tells us right there alone is that this is going to be 5x to 20x. Anytime they ever say a ratio, and you'll see this in geometry stuff too, is when they say the ratio of the sides is 5 to 20, that always implies that there's some sort of multiplier that's taking place. Okay, usually when we say a ratio, we're talking about smaller numbers versus larger numbers, and that's why the x is in there, because that implies larger numbers. Okay, so it's 5x to 20x. They say that there's a total of 800 total students that have voted. So here's what we know: the live students and the DJ students combined together are going to add up to 800 students. So that means that the 5x and the 20x is going to add up to 800. Okay? Put these together, we have 25x, and that's going to equal to 32 for our x value when we divide both sides by 25. Now, what does this mean? That 32 is the multiplier. That means that's the multiplier we use to get to that larger value. So when I say 32 is my x, what I'm doing is I'm taking that 5 and I'm multiplying it by 32 to get how many live people there were. And then we're going to take that 32 and we're going to multiply it by 20, and that's going to give us how many wanted the DJ. So 5 times 32 and 20 times 32 means that we're going to end up with 160 voted for live and 640 voted for DJ. And if you took these two numbers and combined these together, you would see that these add up to 800. And if you reduce these fractions, you could see that they would reduce down to 5 to 20. So it's 160 chose live, 640 chose DJ. So how many voted for the DJ? 640 did. All right, level 3. We're getting to more challenging ones here. Okay. A number is decreased by 30%, and then the resulting number of this is then decreased by 15%. The final number is what percent of the original, okay? So in this case, they don't give us a number. They say a number. So whenever you see this, especially with advanced math, choose a number, because what's going to happen is it's going to be uniform no matter what value I start with. I could start with 100, I could start with 1,000, I could start with 7. I'm going to go ahead and take whatever that number is and decrease it by 30%. I'm then going to take that number and decrease that by 15%. And then I got to figure out what percent of the original number is that. So I'm going to use a real simple number, 100. Anytime I'm working with percentages, I use 100. So let's start first. A number is decreased by 30%. Well, if I have, it's decreasing by 30%. If I have 30% of 100, that's 30. So I'm going to take 30% of 100, which is 30, and reduce it by 30. So 100 minus 30 means now my number, I started with 100, now my number is 70. The next part of this is we're going to go ahead and decrease this number by 15%. So I'm going to go ahead and decrease my number by 15%. So I need to say, well, what is 15% of this number? What is 15% of 70? Well, 0.15 times 70. What we're saying here is 0.15 times 70. That means that that number is going to be 10.5. So if I decrease it by 10.5, we're now down to 59.5 for the new number. So the final part of this question asks you, okay, well, great. Now that we've decreased it by 30 and we decreased it by 15, this final number is what percent of the original number? So 59.5 is what percent of the original number? Well, 59 is the part out of my original number, my total. Remember, this is part out of total. I'm down to 59.5. It's out of 100. And then percent out of 100. If we cross multiply and solve, we still get 59.5%. If I chose any other number, this would actually work out to be exactly the same. It would always equate to 59.5%. Okay? For number 8, Andre and Anthony, they take a jog along the lake. They jog for 25 minutes at a rate of 15 miles per hour. After stopping for a quick rest, they turn around and they take the same path home. The trip back takes about 45 minutes. How fast in miles per hour were they jogging on the way home? Round to the nearest hundredth. Okay, so just keep in mind, we're going to be rounding to 2 decimal places here. So this is a classic problem where it's a rate taking place. And every time there's a rate, you got to check your units very carefully. And it's important to recognize something here. do we see how we're talking about things in terms of minutes, but then over here we've got things in terms of hours? Anytime you see a rate problem, you really have to pay attention to the units that are taking place in the problem. You might have to do some conversions. So here's a conversion that we should know. How many minutes are there in an hour, right? I don't want to work with minutes and hours. I want to work with just hours or just minutes. So if we take a look at this first part of the problem, it says the distance is equal to rate times time. Well, the rate that they're traveling at is 25 minutes. I'm sorry, the time is 25 minutes, but the rate is 15 miles per hour. So it's 25 minutes for 15 miles per hour. Okay, I'm sorry, I switched these two, but it doesn't matter, they're interchangeable. So the rate is this, the time is this, okay? But either way, it still works out the same. Now, I don't want to work with minutes in this problem. Since my units is in hours here, I'd rather not work with minutes. So how do we convert this? Well, what we know is that in 1 hour, there are 60 minutes, right? So I'm going to do that conversion. I'm going to take the 25 minutes and I'm going to say, let's convert this, that for every 1 hour, there are 60 minutes. Why does this work for us and why do we do this? Well, these units of minutes right here and these minutes right here are going to cancel each other out, leaving me with just an hour. Okay, 25 out of 60 hours. And we still have that 15 there. The hours right here and the hours right here now will cancel as well. So if those cancel and my minutes cancel and I look at my units, the only units left in this problem are miles. And that's the distance that we're looking for there. So they travel 6.25 miles. Okay, so 6.25 miles is the total distance. Now he's going to come back. He's got to cover the exact same distance. This time, though, coming back, it's going to take him 45 minutes. So let's do this conversion over here off to the side now. 45 minutes, when converted over to hours, is going to be 45 minutes times 1 hour over 60. That's the conversion rate. The minutes are going to cancel, and what we get is 45 over 60, which is 0.75 hours or 3/4 of an hour. And so we use that, the rate, we don't know how fast they're traveling, but the time is going to be 0.75 hours. Go ahead and divide by 0.75 and we're going to get approximately 8.33 miles per hour for the rate. All right, last question here, level 4. This one's a tough one. I highly recommend you guys really pay attention to this one. It's the summer. This is when people buy mulch. People don't know how to measure. People buy too much mulch and they end up paying a ton for it because they bought too much, or they buy too little and then they have to pay for the shipping fees again in order to get more delivered. So it's good if you know this stuff ahead of time. All right. So Mrs. DiPietro is laying mulch in her garden. The bag of mulch costs $8.25 and each bag covers 6 square yards. Her garden is in the shape of a triangle at the base of 40 feet and 25 feet. How much will Mrs. DiPietro pay for mulch? Look carefully at the units here again, you guys. This is, again, you got to pay attention to units. We have in this problem feet, but then we see it talks about square yards. Yards and feet. We don't want to work with both. So let's convert everything so that we have everything uniformly dealing with the same units. Here's what you need to know. When we're talking about feet over to yards, the conversion rate is that there are 3 feet in 1 yard. So what that means is that when I take 40 feet and I want to look at this in terms of yards, I have to go ahead and divide. Okay, so when I divide, it is 40 divided by 3 yards. So now I don't need this anymore because we're looking at it in terms of yards. When I look at the feet here, there are 25 feet for how tall it is, but we don't want this in feet, we want this in yards. That means we divide it by 3, and it's going to be 25 divided by 3 yards, and I no longer need this unit. So now it's 40 over 3 yards by 25 over 3 yards. Okay? Now let's look at this in terms of a triangle. The area of a triangle, hopefully you know this, is base times height divided by 2. So if I take my values of my base and my height and I substitute these in, take these two and plug these in for my base and my height, we're going to have 25 over 3 times 40 over 3, and then divide all that by 2. Multiply this out, we get A is equal to 1,000 over 9. So this is 1,000 right here over 9, and that's still divided by 2. Throw this into your calculator and you're going to get approximately 37.037 square yards. Okay. From here, we have to figure out, well, how many bags do they need? Well, this is how many square yards it is. And when we look at the problem, we know that every bag can cover 6 yards. And I have 37 square yards. So if I do 37.037 divided by 6, this is going to tell me how many bags I need. Well, I need 6.17 bags. Unfortunately, you can't buy 6.17 bags. You could buy either 6 bags or you could buy 7 bags. And if I buy 6, it's not enough. So I have to buy 7 bags. So if I buy 7 bags, I need 7 bags. Each bag costs me $8.25. $8.25. 8.25 times 7 is going to equal $57.75. There you go. Again, tough section. Go back and watch stuff at your pace. Let me know if you have any questions, okay? Take care until next time.